Now I'm going to do this sequentially here, okay? Slowly. It's kind of hard to capture all the same things. That's basically the range I went through. And when we do experiments with people, most people don't notice the difference. Okay. So this is part of the laboratory here, and this is where the grad students and the medical people and the nursing people are all sort of coming together, working on the protocols. Okay. And what we're doing here is experimenting with all the different functionalities for the circadian design. The next one is direct lighting controls. And so there was a very strong patient-driven issue on indirect lighting. And the idea was to have both the inspection lighting here, which you can see, this lighting here, but also to have user-controlled, but with spectral overrides on indirect. There's a very strong patient-driven indirect lighting preference. And this was preference-driven. And again, going all the way from amber light all the way through to blue light. Amber wayfinding, this is the dark adaptation issue. Okay? This was something that is sort of one of the foundation elements in the hospital design. And the concept is a little bit hard to tell, but this is the view from the bed. Okay? And the idea here is that the specification is to be less than 5 lux, okay, very low level light, red amber spectrum, and to have this driven substantially by motion sensor. Okay, so the idea was that if there was critical kind of movement, baseboards inside the patient room would light up, and then inside the bathroom there would be wayfinding amber light into the bathroom. Okay, no white light, nothing above 5 lux. Okay. It's kind of hard to capture this at night, but the idea was that it's a very low light level, all red amber, enough to get you into the bathroom and back without trips or falls or any disruption. This is a foundation element, and we're getting very strong support in this in elder care facilities, in the zero-net any residential, and the hospital environments. All this was all fully adjustable, so we're looking at different light levels inside this, all the way from threshold lights all the way up. Turns out that at threshold, if you're dark adapted, you can go very low light levels and still maintain egress. As people get older, they start losing contrast sensitivity, and also the recovery for dark adaptation takes longer. So we're experimenting with different levels here. Okay, some older people need a little bit more, but the issue here with the red amber is that you have a lot more flexibility with red amber because it's so far away from the sensitivity curve for your rod function and also for the melanopsin function that you can afford to do this. With the critical issue is you don't want white light or blue light. And then, of course, low amber in the evening. And this is sort of, after sunset, but before sleep, is that someone's just watching television or they're relaxing. You want to have red amber throughout the space. And so this is kind of, again, another adjustable, very difficult to take pictures with this, but all wall perimeters are all amber-based inside the hospital room. So the whole perimeter of the whole hospital room has got this indirect amber. So when the nurse comes to the room, she can get to the bed following the red amber. They can also adjust. This is also nurse controlled. So you turn this on, and then the inspection light. So one of the things that we're working with the nurses on is the control features. We have all the anatomy of this together for the hospital, for the protocol, but the nurses are helping us with what's the controls protocol. Okay? Because some of this you want patients to control, some of it you don't want patients to control. Then the last one is again, I think the foundation, and this is the color rendering one. And this has to do with you're making decisions here. The standard light source that you have throughout the day that changes color temperature and spectral response needs to be 90 CRI or above. The inspection lights also need to be 90 CRI or above. And these are commercially available. There's nothing fancy here. And so both the sort of the high light levels and the low light levels for inspection functions are also all high CRI. And again, it's the kind of thing as, which light source you want to be in a hospital in. You want to be having somebody look at you with this or with this. Okay, and that's kind of a pretty straightforward decision relative to color rendering. So where are we in this whole process, and what's sort of the final outcomes? We're in the process of finalizing the guidelines and the technical specifications. We have the protocol, the basic protocol of all the strategies. Okay, we're set on the strategies. There's good agreement from the medical folks, from the nursing folks, and from the design folks all together. Okay? Right now, we're sort of focusing on the controls program that the nurses will use for the different levels of functionality. Okay? And so we're set. All of these elements here are all set for the protocol. It's really, how do we marry all these things together in terms of how the nurses are going to be using it? We've already finished an assisted living project. We finished a model Z&E house. Currently working on a very large Z&E project that's going to be putting circadian protocol in. And we're doing a new hospital at UCD that will incorporate this. This is sort of, we're about halfway through in terms of putting this together. Questions? Please.
For people that live in extreme latitudes, would you recommend them to use normal daylight as it is natural to them, or?
It's a good question. There's a lot of literature on this, and I'll sort of start this for people who have ever flown across the Pacific on Cathay Pacific. They have color change. I don't know whether people have seen that, but when you go to sleep at night on the airplane crossing, what they'll do is they'll start bringing all the cabin lights down, and they'll start bringing on a low-level blue light. Okay. Which is the idea is that it's supposed to be nighttime, and then when 10 hours later when you're arriving in Hong Kong, they start bringing up the red lights, the amber lights, and so what Cathay Pacific did was they hired a consultant, and the consultant said you need to have this circadian design in which you go from red to blue, but they got it 180 degrees backwards. Okay? What you really want is the no blue when you're going to sleep. And so they did the right thing, they just got it 180 degrees backwards. And so that was kind of an attempt to answer the question, but the idea is you can reset your system by advancing or delaying the blue light. So in other words, if I wake up at 3 o'clock in the morning and I get a lot of exposure to blue light, my body starts thinking that's a little earlier. And so people who want to reset their circadian clock, particularly folks who travel back and forth a lot, they do this. There's already protocols on this. You can reset your system by doing this. Okay? One of the standard things they tell travelers is that when you're traveling, you get a lot of blue light early the next day. It helps you reset your biological clock. So you can do these kinds of things where you could use light to reset your circadian rhythm. And it works with lots of good science on this. So people who live in strange environments that either have access to full days or full nights, you can do that. You can have whatever circadian day you want. You can shorten it, you can lengthen it, you can do. And that's where they found out the guys at Berkeley, when they were working on the Malinowson, they found that people who didn't have visual systems still had circadian rhythm. And that's what gave them the clue that something was going on that wasn't, because most people think that it was all visual system. No, there's another receptor. So you can not fool, but you can manipulate your receptor to move anywhere where it just takes time. So people live in strange, parts of either all full day or full night can do that. There's lots of good papers on this, and the NASA guy who worked on the folks who go up in Skylab and they work up in space, he's at Davis, and we're working together on this. And they have a lab filled with monkeys, and what they do is they shine different lights at them different times, and they can make the monkeys think whatever time of day they want, just by light. It's a good question. Questions, folks? The professor told me you wouldn't be shy. Please.
Is it different for the people from the different countries for this circadian cycle? Or
Yeah. It's a good question. We talked a lot about this relative to color temperature, and this is a contentious issue. Okay? So, in Europe and North America, 2700 Kelvin prevails in residential, hospitality, pretty much everywhere else. In Asia, 6500 Kelvin is sort of the standard light source for most of the time. Now, there's a lot of literature, completely separate from that, there's a lot of literature showing that if you want to maintain sort of ideal hormone balance, you want to have this oscillation in spectrum. Okay, and there's a good scientific. And so this is the kind of thing that we expect in the evening is at lower light levels, we start reducing correlated color temperature, moving into the red ambers. And so there's a biological argument for it, and there's an evolutionary argument for it. But then what explains the prevalence of 6500 Kelvin in Asia? Okay? Because you go anywhere in Asia at 6500 Kelvin, no matter what time of day it is. Okay? So let me give you this argument. Okay? Number of things. One is, we know that at higher color temperatures, that there's an increased perceived brightness phenomenon. And this has been well studied, where if you light two spaces, one at 6500 Kelvin and the other at 2700 Kelvin at the same intensity, the 6500 Kelvin will appear brighter. And the English did a lot of work on this, and they called this visual clarity. Things appeared. There's also another issue. Pupil size reduces. So at the same intensity, higher color temperature, you have smaller pupil. Therefore, your visual acuity is higher. So visual clarity, visual acuity, and perceived brightness have led to a preference for high color temperatures in Asia. Okay. Now, not to be culturally insensitive, but that functionality is what I call temporally insensitive. In other words, the wrong thing to be doing. Which you do not want to go home at night and be under 6500 Kelvin. And that's not an opinion, that's just science. There's a lot of science out there showing we should not have anything in that color region at all at night. It just should not be. The other one is I'm going to argue this, and this is part of the thesis that we're working on, is that in the introduction of fluorescent in Asia, there was a bias towards high color temperatures because blue phosphor fluorescent was both more efficient and cheaper. And Europeans and Americans were reluctant to use that color temperature initially, but the Asians were not. Now, that's a thesis. Okay? So this part is science. This part is thesis. Okay? Now, we have this problem now. In the United States, we're all moving to LED streetlights. And there's a strong move to high color temperature streetlights. That's being stopped as we speak. People, and that will be regulated. We will be regulating color temperature at night in the United States because 6500 Kelvin at night is not good